video, we shall discuss about further pure mathematics 1, May, June 2024, paper 11. Let's take a look at question number 1. The cubic equations 2x cubed plus x squared minus px minus 5 equal to 0, where px is positive constant, has roots of alpha, beta, gamma. State in terms of p the value of alpha, beta, beta, gamma, and gamma, alpha. So for this, it's actually a very straightforward questions. You just need to take this is the product, the sum of the product of two roots. Okay, so it will be equivalent to this value, but need to divide by 2. So it's a negative p divided 2. So that will be the answer for the question A. Then moving forward, part B, they are asking you to find the value of alpha square beta gamma, alpha beta square gamma, and alpha beta gamma square. Just factorize the alpha beta gamma out. You have alpha plus beta plus gamma is inside here. Your product of the three roots will be equivalent to the negative 5 over 2, but there's a negative in front, so it will be positive 5 over 2. Then the sum of the three roots over here, it will be a negative half. So just multiply them, you get this as a negative 5 over 4. Done. So this will be the answer for the part B. Moving on, question C. Deduce a cubic equations whose root is alpha, beta, beta, gamma, and alpha, gamma over here. Okay, so over here, the cubic root, that means just take this, add together. We already know that this answer is negative 5 over 4. And if you multiply all of them together, then you will get this as the alpha, beta, gamma square. Alpha, beta, gamma square is actually negative 5 over 2 square. It will be 25 over 4. Then the product of any two roots, alpha, beta square, gamma, then alpha square, beta, gamma, and the alpha, beta, gamma square. This one is in the part B. Part B, we already found the answer is for part B is negative 5 over 4. Oops. This is negative 5 over 4. Alpha, beta, gamma. Alpha, beta plus beta, gamma plus alpha, gamma. This one is negative p over 2. Okay. So therefore, your new cubic equation will be the x cubed plus the p over 2 x squared plus the negative 5 over 4 x, then minus the 25 over 4. So just multiply everyone by 4, you get 4x cubed plus px squared minus the 25x minus the 25, minus the 5x minus the 25. So this will be the answer for the multiply 4. So this one multiply 4. So this one will be 2p. Okay, so this will be the answer for the question C. Now after that, the D, they're asking you to find the alpha square plus beta square plus the gamma square. So this one is actually alpha square plus the beta square plus the gamma square is actually alpha plus beta plus gamma square minus of this. So this one just now, the sum for this one is negative half. So this is a negative half square minus a 2 of the negative p over 2. they are telling you that they are giving you that this is a 1 over 3. So just join together. You have a P is equal to 1 over 3 minus a 1 over 4. So the answer for P will be 1 over 12. Just like that, done. That will be the answer for the question number 1. Moving on, we have question number 2 here. For question number 2, this is mathematical induction. They're asking you to prove that this statement can be divided by 74 for all positive integers. So first of all, I let this 6 power 4 n plus 38 power n minus 2. I let these expressions, name this as a fn. So when n equal to 1, your f1 will be equals to the, just change the n become 1. Press the calculator, you can see that this is actually 74 multiplied by 18 is divisible by 74. So it's true for n equal to 1. Then assume true for n equal to k. So if we assume n equal to k is true, that means your fk equals to 6 power 4k plus the 38 power k minus a 2 is divisible by 74. Okay, then now we come to the important part. When the n is equal to k plus 1, so we need to show that when n equal to k plus 1, it is also divisible by 74. So fk plus 1 is 6 power 4k plus 4 plus the 38 power k plus 1 minus 2. Taking the fk plus 1 minus the fk is equals to the 6 power 4 minus 1, 6 power 4k plus the 38 minus 1 multiplied by 38 power k. So over here, press the calculator, you get this as the 6 power 4 minus 1. You can actually factorize the power 37 out. This one is also can be 37, you factorize it out. All can be factorized by the 37. Okay, so this is the result, but you don't see 74. This is only 37. So 37 is actually half of the 74. But what you can see is that this is even. This is also even. So even, that means this one is a multiple of 2. Multiple of 2, that means this one is a 37 multiplied by the multiple of 2. That will be 74, multiple of 74. Okay, so this is something you need to take note. So how do we explain in the questions over here? You just need to mention that over here, this is the 37 multiplied by 2m, where m is positive integer. Okay, now just mention that this is a 2m is equals to the 74m. Okay, so your fk plus 1 is equals to the 74m plus the fk. We already know that fk is divisible by 74, and this one is divisible by 74. This one also divisible by 74. Therefore, okay, that means that this one is divisible by 74. So this one is also true for n equal to k plus 1. Okay, so we have successfully shown that this is true for n equal to k plus 1. So conclusion, by PMI, principle of mathematical induction, 6 power 4n plus the 38 power n minus 2 is divisible by 74 for all positive integers n. Okay, so this will be the answer for the question number 2. Done. Now we're moving on to the question number 3. Now question number 3, use a standard result from the list of the formulae that MF19 to show that this summation is true. Okay, so what you need to do now is we just need to expand them. Okay, so this one, if you expand them, you get this one as a 3r cubed plus the 7r squared plus the 4r. Okay, so if you separate them one by one, this is the r cubed, this is the r squared, this is the r. So according to the formula booklet, MF19, this formula is n squared n plus 1 squared over 4. This is a 7n n plus 1 over, oh, sorry, this one is a n squared, so it's 2n plus 1 over 6. This one is a 4 multiplied by n plus 1 over 2. So you can see all of them share the same common factor, which is the n and n plus 1. Okay, so oh, sorry, they are looking for, this n is not the lowercase n, it's the uppercase n. I write the n wrongly. I need to, because I copy down the formula wrongly. This one is supposed to be, the notation supposed to be uppercase n. So I factorize the n and n plus 1 out. These are the common factor for all of them. I also factorize the 12 out because you can see that in front here is 1 over 12. I just take away 12. Then over here, you get this as the 9n and n plus 1. So this one, if you take a 12 out, you get a 14 of 2n plus 1. So if you take a 12 out, this one is a 24. So if you expand and simplify the bracket, last bracket over here, you get a 9n squared plus the 28 plus 9, 37n plus the 38. This one is a 14 and 24, 38. Okay, so we factorize it further. You can see that you have n plus 2, 9n plus 19. Okay, 19 and 18, correct? Okay, so this is the how you get it done. Shown. Okay, so the answer is the same as what's stated here. So this is the answer for the number 3, part A, done. Then I'll go on for the number 2, number 2B. Express this in partial fractions and hence use the method of differences to find this. Okay, so what you need to do is at first 3r plus 4 over the r plus 1. You can use partial fraction to do it. Make it become a over r plus b over r plus 1. But this one will take you a few steps extra. So right here, we try to make it easier by using a shortcut. we can make this become 4r plus 4 minus r. This case is a bit special, so we can do like that. So you factorize it, 4r plus 1 minus r. And if you separate them, you get this as a 4 over r minus a 1 over r plus 1. Okay, you can do like that. So we have successfully used a partial fraction to split them out. So now the questions are looking for the sum for 3r plus 4 over the r and r plus 1. The whole thing here multiplied by 1 over 4 of power of r plus 1. So we just make use of the partial fraction that we have decomposed just now. Put it inside. Then you have 4 over r minus this. And if you put it inside, you will get this one as the 1 over 4 power r minus a 1 over 4 power r plus 1 and r plus 1. Okay, if you expand them in such a way, you can see this. Then after that, you replace the r equal to 1 inside, so it will be 4 times 1 minus a 4 squared times 2. Okay. Then 1 over 4 squared 2 minus a 1 over 4 cube 3 plus the 1 over 4 cube 3 minus a 1 over 4 power 4 times 4. Then dot, because you can see the pattern, they can cancel in such a way already. So the pattern will behave the same until you reach to the last one. It will be 4 power n minus 1, n minus 1. This one is a 4 n, n. This one is the 1 over 4 power n, n minus a 1 over 4 power n plus 1 and n plus 1. So you can see that the pattern will behave in such a way. At the end, it will become 1 over 4 minus a 1 over 4 power of n plus 1 n plus 1. Oh, I still make the same mistake. I still write the n in the lowercase. The n is supposed to be uppercase. So I need to change the n become uppercase n. Okay, need to change the n become uppercase n. So this is the n, this is the n, uppercase n, uppercase n, uppercase n. Okay, so this is the answer for the part B in terms of n. Okay, and then not to forget to cancel everything. Then now after that we are looking for the sum to infinity of 3r plus 4 over the r plus 4 power of 1 over 4 of r plus 1. The whole thing here is the same as a limit of n approaching to infinity for this whole thing. Then at the end, you get the answer as 1 over 4. Just like that. That will be the answer for the questions number C. Okay, number 3C. So moving on, question number 4. Okay, question number 4. Okay, now let's take a look at question number 4. The matrix M is given as this. Then they say that the matrix M represented by the sequence of 2 geometric transformations in xy plane. Give full details of each transformations and make clear in order that they apply. So we know that this one must become first, followed by this one. Okay, so we just need to say that This one we know that is a shear, but not shear. This one is stretch. Okay, this one is stretch. This one is a rotation. Okay, so we need to figure out the rotation. So over here, I just write down this one first. Is equal to the cos theta, sine theta, negative sine theta, and cos theta. So from here, we know that our theta is actually equals to 60 degree. 60 degree, you can write 60 degree, or you can write pi over 3. Okay, so we just say that the m is, oh, no need to say m is 1. Let's say that this one, the transformation is, we have a one-way stretch parallel to x-axis, okay, with a scale factor 14. Followed by, and now we have another transformation followed by rotations anti-clockwise, through 60 degree, or you can say pi over 3, about the origin. About the origin. About origin. Okay, so this will be the answer for the 4A. Then the 4B, they're asking you to write the M inverse is equals to the product of the matrices. So we just let our M is equals to the AB. So your M inverse is equals to the AB inverse is equal to the B inverse and A inverse. So first of all, we need to know this result. So what is our A? Our A is the rotation. So 3 over 2 and half. So from here, how do you find the A inverse? Your A inverse is 1 over 1 over 4 plus 3 over 4. These two values swap. This one you put negative here, you put negative here. So this answer will be half negative sub 3 over 2, sub 3 over 2, and half. Then your B inverse will be what? B inverse will be 1 over 14 minus a 0. These two values swap. Just like that. Okay? Yeah, correct. So this one, it will be 1 over 14 and 1. So therefore, your M is the product of the B inverse multiplied by the A inverse. Sub 3 over 2. Done. That will be the answer for the question number 4B. Moving on. Question number C. They want you to find the invariant lines. Okay, so invariant lines are also quite routine. First of all, we need to multiply the A and B together. Okay, so your M is half sub 3 over 2, sub 3 over 2 and half multiplied by 1401. We need to combine them. We need to combine them together as one, multiply them together as one matrix. Okay, so if you multiply them, you will get this as 7. This is a negative 7 3 over 2. This is a 7 sub 3. And this is half. Okay, so to find the invariant line, we let the invariant line y equal to mx. This is for the object. Then it will become y prime equal to the mx prime. So this is the x, this is the mx, this is the x prime, this is the mx prime. Then this is a 7 negative 3 over 2. This is a 7 3. Okay, so now get ready. So if you multiply them, you will get this one as a 7 minus a 3 over 2m x. Then this is a 7 3 minus a half m. That is equation 1. That is equation 2. Take the equation 1 divide 2 or 2 divide 1. So you get this. So you have a 7m minus a 3 over 2m squared equal to 7 3 minus a half m. Multiply everyone by 2. You get a 3m squared. 1 minus 7. 1 minus 14. Negative 13m. Then plus the 14 3. Okay, so this is the equation that we have, quadratic equations. You can use the quadratic formula to find the m, or if you can, we can factorize it in such a way. So over here, this will be minus a 7 and minus a 2 is a 3. Okay, so you can factorize it. So your m is equal to 7 over 3. Your m is equal to the 2 3. So 7 3, you can write it as a 7 3 over 3. You want to rationalize the denominator. So therefore, your invariant line be y equal to the 7 3 over 3x and y equal to the 2 3x. That will be your two invariant lines. Okay, done. Now we're moving on to the part D. The triangle ABC in the xy plane transformed by m onto the DEF. So this is the image. This is the object. Given that the area of the triangle DEF is 28 cm square, find the area of the ABC. So this is the area of object, area of image. This is image. This is the object. Okay, so we know that the relationship. Okay, we know that the relationship of the area of object is area of DEF is equals to the modulus of determinant of M multiplied by the area of image. So this one is 28. What is the determinant of M? Determinant of M is from here. You find the determinant, it will be 7 over 2 plus the 21 over 2. Okay, 7 over 2 plus 21 over 2. So this one is a modulus 7 over 2 plus 21 over 2 multiplied by the area of ABC. So therefore your area of ABC is equals to the 28 divided by 14. 28 divided by 14 is equal to 2 cm squared. Done. That will be the answer for the number 4D. And moving on, we have number 5. Vector. 3 points ABC have a position vector and they are relative to the origin O. Find the equations of plane ABC in the form of the AX plus BY plus CX equal to D. So first of all, I will write them to the matrix form. 2, 2, 4. This one as a B, OB, 2, 4, -1, and OC as a -3, -3, and 4. So if we want to find AB, vector AB and vector AC. So vector AB, just take the B minus A. You have a 0, 2, -5. Vector AC is a C minus A. You have a -5, -5, and 0. So we just take the cross product between AB and AC, 0, 2, 5, -5, -5, 0. So just cross product, you get a 25I plus the 25J plus a 10K. You factorize the 5 out, you have a 5, 5, 2. So which means my normal vector, I will take the 5, 5, 2 as my normal vector. Okay, just take the simplest integer form. Okay, so once I found the normal vector, so I need to find the equation of plane. It will be the dot product. This is the normal vector. This is the x, y, z. This is any point A, point B, point C. I choose the point A. So just multiply it. 5x plus 5y plus 2z is equal to 10 times 8, 28. So this will be the answer for the number 5A. Moving on, number 5B, you have another point D. So OD, I will write it as a 2, 1, 3. They want you to find the perpendicular distance of D to the plane ABC. Okay, so this plane, maybe I call this plane phi. Okay, so the distance of the D and the phi is modulus of the plane equations. 5x, 5y, 2z is a 5x plus 5y plus 2z minus a 28. Okay, wait, let me squeeze everything inside. 5x plus the 5y plus the 2z minus the 28 divided by the square root of the 5 square plus 5 square plus 2 square. So your x, y, z will be 213. Press a calculator. You get this as the 10, 15, 16, 21 minus 28, 7. 7 over square root of 54. Okay, or you can write 7 square root of 54 divided by 54. Okay, so this is the answer for the question B. Move on, question C. Find the shorter distance between line AB and CD. Okay, so line AB and CD, they are not parallel. Okay, maybe we can write CD first. Our AB, we already have AB, 0 to -5. Then we can find CD. CD is from CD, just take a D here and the C over here to find the CD. Okay, we need to find the CD. So the CD, this one, it will be, wait, the CD is a 5, 4, -1. Okay, 5, 4, -1. So you can see that they are not parallel. and CD not parallel. Okay, now we need to show that they are not parallel, because if that means they are skewed if they have shorter distance. Okay, so if they are parallel, then the way for finding the short distance will be different. Okay, so over here, we just need to take one of the point here, one of the point here. Over here, I take one point called A here and one point called C here, and then I go and find the AC. But AC, just now we already have AC above. AC just now we already have -5, -5, 0. So we have a -5, -5, 0. So what we need to do now is we take these two, we do the cross product. Okay, so we just take AB, cross the CD. So it will be IJK, 0 to -5, 5, 4, -1. Okay, so I just do the cross product. I will get this one as the 20 minus 2, 18i, minus a 25j, minus a 10k. No common factor. We cannot factorize it. Just leave it like this. Then after that, your shortest distance between the line AB and the line CD is equals to the modulus of the dot product between the normal of the ABCD and the AC divided by the square root of 18 square, negative 25 square, negative 10 square. So just press a calculator. You get this as 35 over square root of 1049. Okay, so you can just leave the answer like that. Okay, this is also unit. So this will be the answer for the number 5C. Yeah. And moving on. Okay, this one is question number 6 already. Now we take a look at question number 6. The curve C has the equations y equal to the x squared plus ax plus 1 over x plus 2, where the a is greater than 5 over 2. Find the equations of the asymptote of C. So for these questions over here, we know that we're going to have an oblique asymptote. However, over here, we need to do use a long division to divide them. That will be safer in order to find the oblique asymptote. So over here, if you put x, this one will be x squared plus 2x. This one will be a minus 2x plus 1. So this one will be a minus 2. And if you multiply a minus 2 inside, then you get this one as the 2a minus the 4. So this one, you will get this as the 5 minus the 2a. Get 5 minus 2a. So from here, you can change your equations to become x plus the a minus 2 plus the 5 minus the 2a over the x plus 2. Okay, and from here, we can find the vertical asymptote. VA is x equals to -2, and your OA will be the y equals to the x plus the a minus 2. So this will be the answer for the part A. Now we move on to the part B. Show that the C has no stationary point. So usually when we want to find or show that there's no stationary point, we just need to differentiate the y. So we can differentiate the y over here, or we can differentiate the y over here. So usually differentiate from this part will be easier. Differentiate from here is easier. So I just differentiate from here directly. dy dx equals to the 1 minus of 5 minus 2a over the x plus 2 squared. Then dy dx equal to 0 in order to get a stationary point. So you will get this, oh, sorry. Yeah, correct. Okay, so this one is correct. So if you dy dx equal to 0, then your 5 minus 2a over the x plus 2 square is equal to 1, which is the x plus 2a square is equal to the 5 minus the 2a. So because of the a is greater than 5 over 2, which means the 5 minus the 2a is a negative. Okay. So from this reason, we just say that x plus 2 square is negative. Okay, so this one means that no real solution. Therefore, C has no stationary point. Okay, so this one we have shown that the C has no stationary point. Okay, so now we move on. Sketch and stating the coordinates of the points of intersections of the y-axis and labeling the asymptote. Okay, so we want to find the intersection first when x is equal to 0. What is a y? Over here, you just need to change your y. Just let your x equal to 0, your y is a half. Then when your y is equal to 0, over here, your numerator will become 0. Okay, your y equal to 0, then x squared plus ax plus 1 equal to 0. Then your x is equal to negative a plus minus of the b squared minus a 4ac divided by 2a. So this is a bit complicated to put it on the put it on the diagram. So we just leave it here, keep in view, just in case we need it. Okay. So far, this is what we need to have in order to sketch the diagram. So from here, so I use freehand, but in an actual exam, you use a ruler, and so that you can get a better drawing. Okay, so the scale must be proper so that you can get your diagram more proper. Okay, so x is a 0, y is a half. Then this one is a minus 2. And when the x is equals to 2.5. Okay, wait, your intercept, this one. So when your x equal to 0, your y is equal to a minus 2. When your y is equal to 0, then your x is equal to 2 minus a, or negative a minus 2. Okay, negative a minus 2. So this one we can just approximate. We're not able to get the accurate value. This is a negative 2. So you have a 2 minus a. So it will be something like this. Because it's not a proper value, so we're not able to fully confirm where the location is. So this will be the graph, and this will be the graph. Draw the asymptote features properly. Okay, so these two value is actually belong to here. Okay, but I don't think we need to put it down already. Just make sure that you have two intersect for the x-axis will do. So here, this is one value, which is we do not know, unless we go and separate these equations, and we can get the answer. But I don't think that's needed. Okay, so this is the y, this is the 0, this is the x, this is the y equals to the x plus the a minus 2. So that we have done with this graph. So now the question's asking us to draw the graph with the modulus. So if you draw the graph with the modulus, then actually just from here, you reflect all the graph that is below. All the graph that is below the x-axis, just reflect, go up, will do. So this is my oblique asymptote. Okay, a minus 2. This will be the reflections of the oblique asymptote. Okay, so over here, this is a negative 2. This is a 0. This is a half. So my graph will be like this. And my graph, another one will be like this. Okay, so this will be the graph for the modulus x plus a minus 2. Okay, so this is the graph on the modulus. And then after that, part 2, on your sketch in the part 1, sketch the graph of line y equal to a. So y equal to a will be somewhere here. Maybe I use a different color. Maybe I use a red color to sketch a. This is the graph of y equal to a. So from here, you can see that you have four intersections over here. And these four intersections will be related to the part 3. Okay, so they say less than a. Less than a means we are looking for the region less than a is this region and this region. We're looking for these two regions. Okay, so for these two regions, in order to get the a, we need to let it equal first. Make the equations equal. X squared plus ax plus 1 over the x plus 2 modulus equals to a. Then you take away the modulus. You have a positive a. Another one is a negative a. Another one is this. So over here, you will get x squared plus ax plus 1 equal to the ax plus 2 a. So over here, you get x squared is equal to the 2a minus 1. Your x is equal to plus minus square root of 2a minus 1. Okay, so this one, if you solve it, so okay, actually this one is not needed. This one is not needed. Okay, it's not needed because from here, this is the one that original graph. Okay, original graph with a. So original graph with a, if you refer to the original graph with a, original graph with a over here is like this. Original graph with a. If you refer to the original graph. So these intersections will be representing this one and this one. Original graph. Okay. So from here, you can see that if you compare, this mark is over here. So this is the original graph. If your original graph, this is a tree. Okay, this is a tree. Okay. So your x is a tree. That means when you refer here, when you put it down here, this is a tree. Okay. So from here, there's no need for us to make the thing so troublesome. There's no need for us to have this anymore. We do not need to do this anymore. Okay. So I just erase away the unnecessary things so that we will not going to have so complicated graph over here. Okay. So this one I erase. Oops. Okay. So this is the original graph. Original graph like this. Okay. So from here, your line y equal to 1, y equal to a is over here. Okay, y equal to a. So from here, you can just say that you can just let the square root of from the graph. Okay, we know that the 2a minus 1 is 3 already. So your a minus 1, 2a minus 1 is a 9. So your a is a 5. Just like that, done. That will be the answer for the number D, part 3. Okay, so now we move on. Question number 7. Okay, now we take a look at question number 7. Sketch the C. They're giving you the C as r square equals to the pi minus theta arctangent of pi minus theta, where the theta is from 0 to pi. Okay, sketch a C and state the polar coordinates of the furthest, the point furthest from the pole. Okay, so this one, we drawing the polar coordinate. This is a pole, 0, origin, and this theta is a 0. This theta is a pi over 2, and this theta is a pi. So at the beginning, when you, okay, so over here, if you want, you can build the table here. If you put theta equal to 0, press the calculator, then you will get this. This one you press, use a calculator, press it yourself. Okay. So this one, it will be r equal to the square root of pi arctangent of pi. In terms of radian, so if you press the calculator, then you will can get this 1.99. So that's three significant figure. Then after that, you change this to become pi over 2. If you put pi over 2, then this value will be pi over 2 arctangent of pi over 2 again. Press the calculator, not to forget to square root it, then you will get 1.25. And lastly, this one, if you put pi inside, you get a 0. Okay, so I just plot 3 points over here. So you can see that here is 1.99. This one is a 0. This one is the 1.29, 1.25. So you can see that the graph is getting lesser and lesser. Okay, so the behavior of the graph will be like this. Okay, so it will be like this. Okay, so this will be the graph for the point A, for the graph C. Then we want to find the furthest point. Furthest point is equals to the R theta 1.99 and 0. Furthest point 1.99 and 0. Furthest point from pole. Okay, so this is the answer for the 7A. And move on, they ask you to use a substitution to find the area enclosed by C. So to find the area is a half integrate 0 to pi of R square d theta. So your R square is already given as a pi minus theta arctangent of pi minus theta d theta. So use a substitution. Your U is equal to the pi minus theta. Du d theta is a negative 1. D theta is a negative du. When the theta equal to the 0, your U is a pi. When the theta is equal to pi, then your U is equal to 0. So from here, you can actually change it to become pi, 0, U, arctangent of U, and negative du. So this negative over here, do you see that, do you aware that these two values are reversed? Okay, these two values are reversed. So the negative will make it back to the normal. So the negative over here will make it become 0 to pi. Then you can take away the negative. Okay, just like that. So you make it become normal. And after that, you just need to do the integration by part. This one is u square over 2 arctangent of u minus the u square over 2 of 1 plus u square du. Okay, so you can take away the this is a 0 to pi. Okay, so we take the divide 2 out, then this inside you will get u square arctangent of u minus the u square over the 1 plus u square du. So this is a improper fractions. Improper fractions, we make it proper first. So if we make it proper, just for a while, 0 to pi, we make it proper, we can make it become u square arctangent of u, oops, minus the u square plus 1 minus 1, 1 plus u square du, 0 to pi. So this one, it will be a u square arctangent of u minus the 1 minus 1 plus u square du, 0 to pi. So if you go and integrate it, then you will get this as the this one as a u minus the arctangent of u, 0 to pi. Substitute the value inside, then you will get this as a pi square arctangent pi minus a pi plus the arctangent of pi minus a 0 for everything. So at the end, you will get this as the pi square plus 1 over 4 arctangent of pi minus the pi over 4 unit square. Okay, so this will be the answer for the question number 7B. Okay, so now we move on to the question C. The question C seems a bit troublesome because we need to find the point C furthest from the initial line. So for these questions furthest from the initial line, we need to show this relationship is true. So what you need to do is, first of all, from these equations, pi minus theta arctangent of pi minus theta. Furthest from the initial line, initial line is over here. Then furthest, that means we are looking for the y max. So to look for the maximum y, we need to make this become y. But to make it y, I multiply by sine squared theta. So if I multiply r squared by sine squared theta, I will get this. Okay, so this will become y squared equals to the pi minus theta sine squared theta arctangent of pi minus theta. So to find the dy dx, just do the implicit differentiations. 2y dy d theta is equals to keep the left, keep the middle, differentiate the right. Plus keep the left, keep the right, and differentiate the middle. Oops, not enough space. A bit long. So over here, never mind. I write here, keep the left, keep the right, and differentiate the middle. 2 sine theta cos theta. Then finally, keep the middle, keep the right, and differentiate the left. Okay. So this is what we have. We just let in order to get the y max, maximum value of y, your dy d theta need to be a 0. Okay, your dy d theta need to be a 0. So what you need to do is we just let everything equal to 0. Okay, so it will be 0 equals to the negative pi minus theta sine square over the 1 plus this. Then plus quite long. So this one need to be very careful. Just copy down. Nothing to simplify over here. So we just nothing to simplify. We just make it become, well, there's nothing we can do. Nothing we can simplify. Just make it like this. Just copy down it. Then after that, the last one, it will be minus the sine square theta arctangent of pi minus theta. So what do they want? They want us to show this equal to 0. So you can see that this expression, no sine square. But you can see this expression, no sine square. So what you need to do is we try to differentiate, we try to divide everyone by sine square. Because I have a sine square here, I have a sine square here. So we try to divide everyone by sine square. Okay, so divide everyone by sine square. So you will get 0 equals to the negative pi minus theta over the 1 plus pi minus the theta square. And this one, it will be plus the pi minus the theta arctangent so it will be pi minus the theta arctangent of theta divided by sine square. So you have a 2 cos theta over sine theta. Then this one divided by sine square, you get negative arctangent of pi minus the theta. Oops. Careless again. This one is arctangent This one is okay lah. We direct write to cotangent theta. Okay. So this will be the expressions. Then after that, is it the same as what they want? Oh, it's the same already. Yeah. Right? So therefore, shown already lah. Maybe I write over here. Therefore, 2. This one I write in front. Cotangent and minus this over this minus arctangent by minus theta equal to 0. Shown. Finally. But this one is very tiring. Okay, so this one shown already. Yes, correct. Then after that, we want to verify that these equations have the root for theta between 1.2 and 1.3. Okay, so to do this, we just let this whole function as a theta. Okay, let the f theta look like this. Very troublesome, very time consuming. Okay, we let it like this. So you just need to use your calculator to check whether there's a changes of sign or not. You just put 1.2 and 1.3 inside. Remember to change your calculator into radian mode. In radian mode. Make sure your calculator is in radian mode. So when you press the calculator using the radian mode, then you can get the answer. So to save time, I just direct press it earlier already. I just record down the results earlier. So if you press the calculator with 1.2 with the radian mode, then you get 0.151. This is a positive. This one, if you press the calculator, you get negative 0.395. So you have see that you have changes of sign. Okay, so you just say that because of that is changes of sign between 1.2 and 1.3. Because of this reason, therefore, equation has a root between 1.2 and 1.3. Just like that, finally. Ooh, done. And it's last questions already. Oh, okay, good. So done already. This one a bit long. Okay. So okay, so I'll stop the video, and I'll see you next time in another video. Bye bye.